So 11.3 shifts a little bit in what we're doing. So we're kind of going away from circles and going into regular polygons. So a regular polygon is a polygon in which all of the sides and all of the angles are the same. So everything that we do today, all of the sides of the polygon will be the same length, and then all of the angles at each vertex will be the same as well. So the center of the polygon is kind of like the center of a circle. It's going to be the center of a circle that would hit all of the vertices around the outside. So the center of the polygon would be the same as the center of that circle. Okay, so it's the center of a circle that would contain all the vertices. That kind of went off there, but that says vertices there. So then the radius of the polygon, so imagine there being a circle around this pentagon. And this being the center of that circle. Then a radius would go from the center to the circle. If I drew from the center to the circle this way, that point would not be on the polygon. So it's not considered a radius of the polygon because this particular radius of the circle did not actually hit any part of the polygon. So there's a couple of different parts of the polygon that we're going to talk about. So the first one is radius. So that one is going to go from the vertex, from the center to a vertex. So the radius of a polygon goes from the center to the vertex. Okay, so this is our radius. Okay, so I'll write it out on that one, but as we get further, we'll just call it R. Okay, so then this next one is called the Apothem in the Midwest, or the Apothem if you're in some other states, depending on how you pronounce it, but in the Midwest it's called the Apothem. The Apothem is going to be this other distance that I was kind of talking about as not being the radius. So it's going to go from the center and it's going to be perpendicular to the side of the polygon. It's also going to cut the polygon in half. Okay, so it's going to go from the center of the polygon to the midpoint of a side. And just as a side note, it is perpendicular. Okay, so this distance here, whatever this is going to be the same distance. So we'll just keep that in mind. So this is called the Apothem, and it'll be denoted with a little a. And that right there is the Apothem in the picture. Now, because I've kind of written all over this, it's going to be hard for me to show you the central angle of this particular polygon. So the next one is the central angle of a polygon. But the central angle, so I'm going to come over to this one to show you the central angle. So the central angle is the angle at the center, okay? But more specifically, which angle at the center? So the central angle is this angle here. So that angle, the central angle, is going to be the angle at the center between two radii. So this is a radius, this is a radius, so the angle between two radii. So it's the angle the center, and it's between two radii. Okay, now that angle is going to become very, very important as we move forward. So now what we're going to do is we're going to talk about how to find that central angle. So I used this a lot to kind of talk about the different parts that we're going to be using, but we're going to find this central angle on these particular polygons. Now this is a 5-sided polygon, so that's a pentagon. This is 6-sided, so this is a hexagon. This one is 1, 2, 3, 4, 5, 6, 7 sides. So 7 actually has 2 names. So it's a septagon or a heptagon, either one. And then this one over here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's our decagon. Okay, so let's talk about the central angle. Well, if I were to draw each one of these central angles, and remember they're all going to be the same because this is regular, there would be 1, 2, 3, 4, 5, 6 central angles, and all of them together, do you see how those go around to make a circle? So that's 360 degrees. So if you take 360 degrees and you divide it by 6 central angles, you will find that that central angle is 60 degrees. That's the central angle. Okay, remember this is a 7-gon or a septagon or a heptagon. So that's going to be 360 divided by 7. Okay, so throw that in our calculator, 360 divided by 7. And there's no rule about this having to come out to be a perfect number, so this is going to be 51.4 degrees. Now I know I usually tell you to round it to the nearest whole number for a degree. That's when the degree measure is your answer. So this isn't our answer yet, so we can round kind of out a little bit farther to get a more exact answer as we go. But if you're rounding at the very, very end of a problem and it's an angle measure, let's keep it to the nearest whole number. Okay, and then this one right here again, so that's this angle right here is 51.4 degrees. And then the same thing, do it one more time for this one, decagon. So 360 divided by 10 is 36. Okay. So what we're going to do, though, is as we go through the problem, we are actually going to be using this triangle. So if you kind of go back to what we were talking about with the central angle, the central angle is this whole angle right there. It's this angle. That's our central angle. So if I take 360 and divide it by 5, because this is a pentagon, you get 72 degrees. But what you'll notice is the triangle that I'm actually going to use is only this half of that central angle triangle, because I want to have a 90 degrees. So what we're going to do as we go down and actually find the area is we're going to take that 72 degrees and we're going to break it in half. We're going to break it into 2 equal parts. So 72 divided by 2 means that this angle would be 36 degrees, and this angle here would also be 36 degrees. Okay, so we'll kind of keep that in mind as we go and as we find the area, because we're really just dealing with this little triangle in here. Okay, and then we'll use that to find the whole area. Okay, so we talked about central angle, kind of all the way across, but now we're going to actually talk about area. Okay, so example 2, we're going to go back to that pentagon. We're going to go ahead and find that central angle. That's always going to be step 1 because you need that angle measure. Okay. So this central angle right here is 72 degrees. So 360 divided by 5, that is 72. That is 100% true. But we are going to find the area of this triangle right here, which is 1/2 base times height. So the area of this triangle is going to be 1/2 the base times the height. If I draw the height in here, there's my height. That height has a special name, right? So it is a height, but more specifically for this triangle, it is called the apothem. So what we're really doing is we're doing 1/2 the base times the apothem. So this formula kind of morphs a little bit to 1/2 the base times the apothem. Well, then I'm going to change it up on you again, because this is actually not called a base for a polygon. It's called the side length. It's actually given in the letter S, which I hate because it looks like a 5, but that's actually going to morph to the letter S for side length. Okay, so that's 1/2 the side length times the apothem. Okay, so let's just do that part, and then we'll kind of go over the next little bit here. Okay, so I haven't given you any numbers yet, which is very true, but what you'll be given on like the first problem, for example, is that the side length here, let's say the side length is 8. Okay, so if the side length is 8, then this piece right here would be 4, and this piece right here would be 4 as well. Okay, hopefully you're still with me. This angle here, right, we said 72 is the whole thing, so 36 degrees is right there for that angle. So then we need to find the apothem. So we're going to reach back into our bag of tricks, and if you have a right triangle with a 36 degrees, and you know that the opposite side is 4, and you're trying to find the adjacent side, you're going to use tangent. Okay, so it's been a while since we've done that. So toa is our trig functions. So opposite and adjacent is tangent. So the 4 is my opposite, the A is my adjacent, so this would be your opposite side. So it would look like this. Tan 36 is equal to 4 over A. Okay. Let's go ahead and solve that. Now again, you're just getting used to using that Desmos app if you're using it, or using whatever calculator you have at home. So I just want to go through this again because it's the first time that you've ever used it. So on the Desmos app, every time you open it, every time you pop that app open, you have to turn it to degrees. So to do that, let's see here, 1 second. Let's see if this helps. Better or worse? Worse. Let's do this. Hey, there we go. Okay, so right at the top here, there's a little wrench looking button. You need to click that wrench button, and every single time you pop open the app, you have to change it to degrees. So kind of down at the bottom of that menu, it says radians or degrees. You need to click this degrees right here so that it knows you're going to be giving it 36 degrees. Okay, so this button here needs to be clicked. So if you're not getting the answers on the back, check that first, okay? All right, so I'm going to go ahead and click off of that. Then I'm also going to show you that when you tap to go ahead and start writing your first equation here, in order to get tangent, tangent is inside of this functions menu. So inside of the function menu right here, you'll find your sine, cosine, and tangent. Okay, so to solve this, it's been a long time, so maybe you don't remember, we're going to cross multiply. So I'm going to take 4 times 1, which is 4, and I will multiply that times the tangent of 36. Okay, and then I'll get this answer. So 2.91, we'll say. Okay, 2.91. So my apothem is 2.91. Now, why did I even get that? Well, again, our formula is 1/2 the side length times the apothem. Okay, so that's going to be my area. So the area, this is an area formula. Okay, so big A, little a. So my big A is going to be 1/2 of my side length times my apothem. So 1/2 of your side length, my side length again was 8. So can I just group these two together and say 1/2 of my side length is 4? Yes. And then we're going to multiply that times 2.91. So that gives me an answer of, so I'll multiply my answer here times 4, and I get 11.62. Okay, now we have to be careful. This is a long process, so please, if you're confused at this point, please just stick with me, and we'll do a couple of examples to make you feel a little bit more comfortable. Okay, now this was just the area of one triangle inside this pentagon. How many of these triangles exist in the pentagon? Well, there's one there, 2, 3, 4, and 5. So this is triangle 1, 2, 3, 4, 5 of those. So my last step then is to multiply this times 5, because there are 5 triangles inside of that shape. So the answer that you would see on the back, we're doing this all in terms of like all decimal numbers, so don't worry about leaving anything in fractions or pi or anything like that. Just throw that all out the window. We're going all decimals. So this is 58.12, and it would be units squared. Okay, we got to try that again because that was a lot of information thrown at you, and you have to get comfortable with it. So stick with me. I promise we'll get to know this a little bit better. Okay, but let's do this again. All right, so we're going to start with the side length this time. I'm going to tell you that the side length here is 10. So let's just pretend that the side length of this regular polygon is 10. Okay, so I'm going to draw just this one triangle because that's really all I need. I'm going to find the area of this triangle, from the area of that triangle, and then I'm going to multiply that area times how many triangles there are. So there's going to be 1, 2, 3, 4, 5, 6, 7 triangles, which is really just how many sides it has. So once I get the area of this triangle, I'll times my answer by 7. Okay, so I'm going to take this triangle, and again, I've got the answer up here for the angle measure, this 51.4, because that's the same shape, but I'll just write that process out so that you can have that process down even when we turn the page. Okay, so you always start by finding that angle measure, which is 360 divided by the number of sides, which is 51.4. So this entire angle here is 51.4. What I'm going to do is I'm going to break that triangle in half so that I can do 1/2 base times height. So my 51.4 needs to be divided by 2. So 51.4 divided by 2. My angle measure that I'm going to be using is going to be 25.7 degrees. Okay, so this angle in here is 25.7. Now this 10 is going to get broken up into 5 and 5. and I'm going to label this as A. Now I'm ready for my tangent. So far, we will pretty much always be using tangent because here's my hypotenuse. My hypotenuse is that radius, and there's no number on there, so that's not involved. So this is going to be tangent here again. So tan 25.7 is equal to opposite over adjacent. Okay, so this is where you grab your calculator, and we're going to do 5 times 1, which is 5, and we'll divide that by the tangent. When I type that in, you can push pause if you need to actually type it in yourself just to see. But I got my apothem to be 10.39 if I round. Okay, so that's this number right here. Okay, so my area formula is half the side length times the apothem. And then, don't forget, you're going to take that number times 7. So half of my side length, you can kind of tuck those two things together because you can see what half of your side length is. It's 5. Times the number I just got, 10.39. And then we'll times that by 7. You can go ahead and do all of that all in one line, or you can do it separately. It's kind of up to you. So if you just times by 5, you'll get 51.94. And then don't forget you have 7 of those triangles. Okay. This is where it's going to be super important that you check your answers with the back to make sure that you're on the right track. Because when you take the quiz, this is all that's going to be on the quiz for this section. The 11.3 quiz will only have the area of regular polygons on it. So make sure that you're checking your work to make sure you're on the right track with these particular types of problems. Okay, I'm going to turn the page, and I'm going to do a couple more problems just like this, and then I'll let you go. Okay. So we're going to go up here to this first one. It's super blurry, sorry about that. The side length here is 9. This is a 1, 2, 3, 4, 5, 6, 7 again. So I'm going to use those same angle measures that I was just using. You can make your triangle wherever. So since the 9's right there, you can make your triangle there. Let's cut that 9 in half. Bring down your apothem. So here's my apothem. This is going to be 4.5. Okay, and then this angle measure is found by doing 360 divided by 7, and then you'll take all of that and divide it by 2, which we just did. And we were using the number 25.7. Okay, so let's set up our tangent. So 4.5 divided by tan of 25.7 gives me 9.35. So my apothem here equals 9.35. When you're doing your work for this, like especially doing the quiz, this number and this work is probably the most important part of it. So now we're going to take half the base times the apothem times the number of sides that this thing has. And so from there, getting the final answer, there's not a whole lot of work that you would need to show, but all of this is the really important work. Okay, so again, for our formula, we're going to take half of the side length, we'll multiply that times the apothem, and then we'll multiply that by the number of sides the shape has, which is typically an n for number of sides. Okay, so if you happen to see that n there, or if I just accidentally revert back and write it, that n means the number of sides that the shape has. So half the side length, that's our 4.5. Our apothem is 9.35. And then the number of sides this thing has is 7. Okay, so if you multiply those three parts together, that's the whole thing. It's the whole shebang. You got it? Which is 294.5. Okay, if you want to, you can pause the video right now and you can try the problem that's directly underneath that with the 7 so that you can kind of see, and then you can play the video when you're ready and see if your answer matches up. Okay, and if you're thinking like, okay, I'm kind of getting this, that is awesome. It's amazing. I am going to switch it up on you on the next video. There's a second part of this, and you're going to see that. But we're going to stick to just this first type today, and then we'll see a couple of the more difficult problems next time. All right, let's look at this one. So I'm going to break this in half. Here's my apothem. 3.5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 360 divided by my 10 sides, which is 36, but I need to cut that 36 in half because I have cut my triangle in half to put the apothem there. So that means this angle measure is going to be 18 degrees. Okay. All right. So tangent of 18 is equal to 3.5 over A which gives me 10.77. And now I'm ready. I'm ready to take half of my side length times the apothem times the number of sides. So my half side length is 3.5. I'll multiply that times my apothem, which I got 10.77. And then I'll multiply that by 10 sides, which is 377.02 if I'm rounding. Okay. On the practice that says practice 11.3, okay, there are 2 pages of this, but what we are going to just focus on today is the ones that you are given the side length. And what you're going to see here is that there are problems where you're not given the side length, you're given something else. Okay, so we're going to focus on this one here, number 15. This one down here, number 18. This is a number 5, by the way, if you can't tell what that is. Okay. Then if you turn the page. Number 14 is the only 3 problems that you can do from this set so far. Okay, so try just those 3 problems, and then when we come back for 11.3 the second day, then we'll get into the other types.